Okay, so this is the final concept, and with this lecture, we will be marking the end of this topic, roots of polynomials. So after this, we will be able to solve all the questions from the past papers. And yeah, let's get started. I have taken out these 4 questions from the past papers, from which we will be learning the method of substitutions. There are different cases, case 1, case 2, case 3, and case 4. With each case, there's something unique and something different. Okay, so let's get started with case 1. So the question is asking the cubic equation x cubed plus bx squared plus cx plus d is equals to 0, where b, c, and d are constants, and has roots alpha, beta, gamma. It is given that alpha, beta, gamma, which is product of roots, is equals to -1. And it's asking us to state the value of d in the first part. So we already know that the product of roots alpha, beta, gamma is equals to minus d over a. The coefficient with x cubed, which is a, is 1, right? So we can write this as alpha, beta, gamma is equals to minus d. And we are given the value for product of roots, which is -1. So -1 is equals to minus d. Let's make d the subject. So d is equals to 1. This is our final answer. Now, this is something we are learning. The second part asks us to find a cubic equation with coefficients in terms of b and c whose roots are alpha plus 1, beta plus 1, plus gamma plus 1. Okay. Now, our objective is, the question is basically asking us to write an equation whose roots are these. Okay. Not these. Okay. So how will we do that? So our objective is to write the equation in terms of y. I mean, yeah, in terms of y. And how can we do that? So as we know that these roots are basically values of x, right? Here too, these roots are basically value of x. Okay. So since they are the values of x, we can simply write them as a single equation, which is x plus 1, right? This x represents alpha, beta, and gamma. They are basically the values of x. Okay, so we now simply equate this equation to y. Okay, so now let me change the color. Okay, so now we have this equation, y is equals to x minus 1. Now we will make x the subject by taking 1 to the other side. So this will be y plus 1 equals to x, right? Yeah, never mind. This is plus, hence this will be plus, and this will be y minus 1. Okay, we have written the equation we formed using the roots and put it equals to y and made x the subject. Okay, now can we input the value of x in terms of y in place of x in this equation? Yeah, we can do that. So let's actually do that. So this is our equation. Let's just input this instead of x. So yeah, this will be y minus 1 cube plus b y minus 1 square plus c y minus 1. And we have found the value of d, which is 1. So we can simply write 1 here. And all of this is equals to 0. Okay, now let's simplify this by expanding these. So y minus 1 square would be y square minus 2y plus 1. And y minus 1 cube would be basically this multiplied by y minus 1. So let's do that. So we will end up with y cube minus 3y square plus 3y minus 1. Let's input this. So we will have this y square minus 2y plus 1 plus b, my bad, y cube minus 3y square plus 3y minus 1 plus b, and expansion of y minus 1 square, which is y square minus 2y plus 1 plus c, y minus 1 plus 1 equals to 0. Okay, so now let's expand everything. So this will be y cube minus 3y square plus 3y minus 1 plus by square minus 2by plus b plus cy minus c plus 1 equals to 0. Now let's see if anything is cancelling. Yes, there is. Minus 1 and plus 1 is cancelling out. So now let's write like terms together. Y cube minus 3y square plus by square plus 3y minus 2by plus cy plus b minus c, and all of this is equals to 0. Now let's take y term common. So this will be y cube minus 3 plus b y square plus 3 minus 2b plus cy plus b plus c equals to 0. So this is our equation for these roots. So this is how substitution works, and this equation is known as substitution. Sometimes this is given in the question. We will come across those questions as well. So yeah, this is how the substitution method works. One thing I glossed over here is when I write x equals to y minus 1, x equals to y minus 1, that's not the answer. It's a translation rule. The reason we substituted it back into original equation is because that's the equation we know which is true. For example, if we were to input alpha, beta, and gamma in place of x, the equation will still equals to 0. So that's a true equation. So if we were to input this substitution in terms of x, the equation will still equals to 0, making it still true. So that's why we use this substitution method to find equation for roots like these. Okay, so case 2. The question is asking the roots of cubic equation 2x cubed plus x squared plus minus 7 is equals to 0 are alpha, beta, and gamma. Using the substitution, y equals to 1 plus 1 over x, or otherwise find the cubic equation whose roots are 1 plus 1 alpha and so on, giving your answer in the form ayq plus by squared plus cy plus d equals to 0, where a, b, c, and d are constants to be found. So we have to find the equation, and using that equation we have to find the value for a, b, c, and d. Okay, so substitution in this case is already given. We could have done that ourselves as well, but since it's already given, we can just make x the subject. So y is equals to 1 plus 1 over x. Okay, so let's make x the subject. So this will be x plus 1 divided by x. I took LCM, so which is equals to y. Y and x gets multiplied. Y x equals to x plus 1. Let's take this x to the other side. This will be y x minus x equals to 1. Let's take x common. This will be y minus 1 equals to 1. So x is equals to 1 over y minus 1. So this is what we will be substituting in the equation they have given. So now, as you guys see, that we are actually dealing with fractions. So this will be quite tricky. So let me first input this, and then let's see what to do. So we will have, okay, so 2, 1 divided by y minus 1 cube plus 1 y minus 1 square minus 7 equals to 0. Okay, so now let's simplify this. This would be 2 divided by y minus 1 cube plus 1 y minus 1 square minus 7 equals to 0. Okay, now of course we are dealing with fractions. It would be a bit harder. So let's say that let's multiply whole equation by this to eliminate fraction. Okay, so we will multiply the whole equation by y minus 1 cube. Okay, let's multiply the whole equation by y minus 1 cube. So this and this will get cancelled. This will just get cancelled. We will be left with 2. Okay, 2, and this will also get cancelled, leaving us with only y minus 1 in the numerator. So we will have this plus y minus 1, right? So, and now since this is being multiplied and there is nothing being cut, so this will simply be multiplied with y minus 1 cube, and all of this is still equals to 0. Okay, okay, so this will be 1 plus y. Let's expand this, minus 7. Let's expand this over here. So y minus 1 square is equals to y square minus 2y plus 1. Okay, so we need y minus 1 cube. Y minus 1 cube. To get y minus 1 cube, we will multiply this by y minus 1. So let's do that. So this will be y cube minus 3y square plus 3y plus 1. Let's input this here. So this will be 7y cube minus 3y square plus 3y plus 1. Okay, so now, now 1 plus y minus 7, 7 gets multiplied, minus 7y cube plus 21y square minus 21y minus 7. Okay, all of this is still equal to 0. So, okay, so I forgot to write the minus sign here. So now let's simplify this. So this will be minus 8. This will be 20y and 21y square. 21y square minus 7y cube equals to 0. Now let's make the highest coefficient positive. So this will all go towards the other side, and this will be 7y cube minus 21y square minus 20y minus 8 equals to 0. Now we can find the coefficients a, b, c, and d. So let me copy and paste this and let's compare. Okay, so value of a is 7. A is equals to 7. B is equals to minus 21. C is equals to minus 20. And lastly, D is equals to minus 8. So whenever we are dealing with fractions, we will always first try to eliminate them. Okay, so yeah, let's get started with case number 3. Okay, so case 3. The equation x to the power 4 minus 2x to the power 3 minus 1 is equals to 0 and has roots alpha, beta, gamma, delta. So part A is asking us to find the quartic equation, whose roots are alpha cube, beta cube, gamma cube, delta cube, and we have to state the value of sum of cube of roots. Sum of cube of roots is here. Okay, so first of all, as I said earlier, the roots are basically values of x. So we can write them all as a single expression, which is x cube, right? This represents x cubes, okay? And let's put it equals to y. And this is our substitution, okay? Now let's make y the subject. How can we do that? By taking cube root both sides. So we will be left with cube root of y. If we were to recall indices, rules of indices, we can actually write square of x as x with power of 1 over 2. Similarly, if we had cube root of x, we can actually write it as x to the power 1 over 3. So we will be applying same rule here, and we can actually write x is equals to y to the power 1 over 3. Okay, this is what we will be substituting in. So let's try that. So x to the power 4, 1 over 3. This is in place of x to the power 4 minus 2 y to the power 1 over 3, power of 3 here, and minus 1. And all of this is equals to 0. Okay. Okay, now what we can do is multiply numerator with the power outside. This will be y to the power 4 divided by 3. Similarly, it would be 2y here because 2y 3 over 3. If 3 multiplies by 1, it will become 3's. And 3 and 3 cancels each other out. So this will simply be 2y minus 2y and minus 1 as it is. Okay, so now what we have to do is, okay, so now let's separate y with fractional power so that things are easier for us to simplify. So this would be y 4 over 3, and let's separate everything. So 2y plus 1, these two will go towards the other side. So this is what we have now. Now let's simplify this by multiplying whole equation by q. Okay, so this will become y to the power of 4. Why? Because this becomes this, 3 and 3 gets cancelled, and we are left with y to the power of 4. So now we have y to the power 4, which is equals to 2y plus 1 with cube over all of it. Okay, so now let's expand this, and yeah, we will be left with 8y cube. I'm doing this directly, plus 8y square plus 2y plus 4y square plus 4y plus 1. If we were to simplify this, this would be 8y cube plus 12y square plus 6y plus 1. And all of this is equals to y to the power of 4, y to the power of 4. Now let's make them as a single equation, which is equals to 0 by taking everything to the other side. So this would be y to the power 4 minus 8 power 8y to the power 3 plus 12y square plus 6. Okay, my bad. This will be minus 12y square. This will be minus 6y square, not square, and plus 1. And all of this is equals to 0. This is our equation. We have fulfilled the first condition of finding the quadratic equation. Now we have to find the value for this. Okay, so now we have to find sum of cube of roots. Okay, now what we have to understand is that alpha plus beta plus gamma plus delta, this is equals to S1, right? and alpha square plus beta square plus gamma square plus delta square is equals to S2, and alpha cube plus beta cube plus gamma cube plus delta cube is equals to S3. Okay, now what we have to do is we have to find the value of S3. How can we do that? So we have two methods. One is efficient, one is less efficient. The less efficient one here is obviously finding the value of S1 first, then S2 first, and then finding S3, which will just take too long, right? So there's an actually easier method which we can apply here, which is that the equation we found, the S1 of this equation is equals to S3, S3, right? Like for example, S1 of this equation, which is alpha plus beta plus gamma, is equals to alpha plus beta plus gamma. Since the roots of our new equation are cube, and we have found the equation on basis of these roots where they are cube, so then our new equation S1 is equals to S3 of our original equation. Okay, so in short, S3 of old equation, let me write for S3 old is equals to S3 old is equals to S1 of new equation. Why? Because in our older equation we had roots alpha, beta, gamma, delta, with all of them having a power of 1, right? And in our new equation we have roots alpha cube plus beta cube, not plus, alpha cube, beta cube, gamma cube, and delta cube, with all of them having a power of cube. Okay, so this is our relation which can help us find the which can help us reduce the steps, because if we were to find S3 using our older equation, we have to find the value for S1, S2, and then finally S3, but we can skip all of that and find the value of S1 of our new equation, which is this, and S1 is equals to minus B over A always. So value of A is 1, since there is no coefficient next to y to the power 4. So 1 divided by minus, and b is minus 8. So s value of S1 is 8. Now this S1 8 is equals to S3 of our older equation, our original equation. Okay. So yeah, that's what I have to explain. Now we have completed the first part. Okay, so now let me erase everything. So what we needed to understand, S3 original equation is also equals to alpha cube plus beta cube plus gamma cube plus delta cube. And S1 of new equation is also equals to this. Okay, so that's what I had to explain. So now we have to find the value of inverse of sum of inverse roots. Okay, now part B. Okay, part B. The part B is asking us to find sum of inverse of roots that are cube. Okay, so yeah, if we were to take LCM for this, this would be also, yeah, this equation is actually equals to s minus 1 of our new equation, because our roots are basically inverse, whichever these alpha cube plus beta cube plus gamma cube plus delta cube, they are inverse. So this is equals to alpha, I mean s minus 1. Okay, so if we were to use our original equation, this would have been equal to s minus 3 of our original equation. Okay, so yeah, now we will find this using our original equation. So let's try that. So s minus 1 is equals to this. We have to take LCM for this. This will be alpha cube, beta cube, This will be alpha cube, beta cube, alpha cube, beta cube, plus gamma cube plus delta cube, gamma cube plus gamma cube multiplied by delta cube. So in the end, if we were to do this again, this we will end up with alpha cube, gamma cube, beta cube plus alpha cube, beta cube, delta cube plus alpha cube, gamma cube, delta cube plus beta cube, gamma cube, delta cube divided by alpha cube, beta cube, gamma cube, delta cube. Okay, so this is product of our roots of for new equation. Okay, so product of roots, and this is sum of triple pair of roots. Okay, so in quartic equation, yeah, sum of triple pair wise roots is equals to minus d over a, and product of roots is equals to a over a. So we can apply that here. So since the value of a is 1, you don't have to write it. So this would be minus b divided by e. Okay, sum of inverse of roots. Now let's see the value for minus t and e in our new equation. Oops, there is a sign error. This goes towards the other side. This will become minus 1. Okay, so the value of d is minus 6. Minus 6. Value for e is minus. What the hell is happening? Value of e is minus 1. So this becomes 6 minus 6. This is our answer for part B. Now for part C, okay, for part number C, we have to find alpha to the power 4 plus beta to the power 4, sum of roots with all of them having a power of 4. Okay, we have to find this. Now we can't use our original equation to find this. We can't, because the relation between these equations was that if it was S1, if our new equation was S1, our original would have been S3. If it was S2, this would have been S6, right? This was our relation. This, yeah, this was our relation. Now, if we have S4, what is that equals to? Of course, we can't tell that. So we will use recurrence we learned in the last class here. So we already know the value of S3. Right? We know the value of S3. What is S3 is equals to S1 of new. What is S1 of new equals to? S1 of new is equals to is equals to 8. So S3 is equals to 8. Right? So S3 is equals to 8. Now S2 of our original equation. Original equation was this one. This is our original. Okay, so what was the value of S2? Let me actually copy and paste this below as well. Okay, so how did we use to calculate the value of S2? We had this formula minus B over A square minus 2C over A, right? The value of A is 1, so this would be 4. Yeah, this would be 4 minus 2. Value of C, we have no value of C. So this is basically 0. So S2 is equals to 4. Now what is S1 is equals to? S1 is equals to minus B over A, which is 2. Right? So now we can use recurrence method to find the value of S4, which would be, this would be S4, x cube would be s3 minus s3. We have no value of s2 here, so it will simply be 0. Same for s1 and our s0. Our s0 is given. This is basically x0. So using recurrence, we will end up with this. We can now simply make s4 the subject. So s4 is equals to minus 2. S3 was 8 minus 4, as the value of s0 is same as degree of our original equation. So yeah, this would be s4 minus 16 minus 4. This would be s4 equals to 20. This is our final answer. Let me recheck it. Yeah, s4 is equals to 20. Now I added one more part to this question, which is finding this. We have to show that this is equals to 88. So how can we do that? Now we will use the same relation we formed using this equation, right? Our new equation. What was the relation? That S1 of new equation is equals to S3 of 4 and S2 of new equation is equals to S6 of 4, right? So what was our new equation? Our new equation was this. Let me copy and paste this. Copy. We know the relation between the old and new equation, that S1 of new equation is S3 of 4. S2 of new is equals to S6 or. Now we need to find S6 here. This is basically S6, right? I forgot to write this here because I made this question myself. This is delta to the power 6. Yeah. Now we can solve for S2, which would be S2 is equals to minus B over A squared, the same formula we have been using, plus C or minus 2C over A, my fault, minus 2C over A. Okay, so this would actually be equals to, what's the value of B? 8 and 1, this will be 64, minus 2, what's the value of C? C is AB. C is minus 12, this would be 24, plus 24, and the value of S2 is 88, hence we proved it. So this was case 3, which can come in your exam. And now we are left with our last case, which is case 4. Okay, so let's get started. The equation x cubed plus 2x squared plus x plus 7 equals 0 and has roots alpha, beta, gamma. Let's rewrite the equation. X cubed plus 2x squared plus x plus 7 equals to 0. Okay, so the part 1 is asking us to use the relation. The relation is already given. Okay, so we have to find this using the relation and this. I have already made the pointers. We have to find the equation and we have to show that the equation has these roots. The roots aren't given, so this is something new and important. So let's try this. So I have already rewritten the equation. So yeah. Okay, so we have to use this substitution. X squared equals to minus 7y. We can either do like this, like again x equals to minus 7y root. We can either do this again, or there is a easier, simpler method for questions like these, where we separate even and odd powers and then square them to make them all evens. Okay, so let's try that. So we have even and odd powers, odd, even, right? X to the power 0 is even. So let's separate them. So x cubed plus x on one side and all the even powers on the other, minus 2x squared minus 7. Okay, now we are gonna make the even powers, we are gonna make the odd powers even now by squaring everything in our equation. Okay, so in the end we will be left with x cubed plus x square equals to minus 2x squared minus 7 and everything squared. Now let's expand these. So now we will be left with x to the power of 6 plus 2x to the power of 4 plus x squared, which is equals to 4x to the power of 4 plus 28x squared and finally plus 49. Okay, now let's take everything to one side. So this would be x to the power of 6. I'm simplifying as well. So this would be minus 2 x to the power of 4 minus 27x squared plus 49. And all of this is equals to 0. Okay, now let's leave this. Now everything is even, right? So we can easily substitute this directly, right? So this would be this would be minus 7y to the power of cube, because x squared is equals to minus 7y. So x to the power 4 would be equal to minus 7y squared. So this is what we are using here. So this would be this, and this would be minus 7y squared minus 27 minus 7y plus 49 equals to 0. Let's expand this. This would be minus 343 y cube minus, this would be minus 98y square. This would be plus 189. Okay, so this is negative. See, I made a mistake. Minus, so this is square. Okay, so 49. Okay, so this is 189y and this is minus 49, and all of this is equals to 0. Now let's make the highest degree positive. So this will be 343y cube plus 98y square minus 189y minus, no, plus 49 equals to 0. Now we are left with this. We have to make this somehow, right? So we will divide everything by 7. So let's try that. 1 over 7. This becomes 49y cube plus 14y square minus 27y plus 7y, not y, plus 7 equals to 0. And we have shown our equation. Okay, now for the second, not the second part, we have satisfied this, and now we have to show this. Okay, how can we show this? Okay, so this requires some analyzing. So we know that, let me rewrite it, x squared is equals to minus 7y, right? Let's make y the subject. So y is equals to x squared minus 7. Why we made the y the subject? So we can have this form. This is equals to y, right? We have to equate it to y because we are doing the reverse process here, okay? So yeah, let's go back to this. Now, there's one thing to analyze here. First, this is a cubic equation, right? So this x actually here represents alpha, beta, and gamma. Okay, so we can substitute these one by one in place of x. Okay, and another thing to notice is that this is equals to alpha, beta, gamma, product of roots. How? Because as you guys see, the product of root is minus d over a. The value of uh a is 1 and d is 7, so this would be minus 7. which is equals to product of roots. So can we write our equation like this? X square divided by product of roots alpha, beta, gamma. Right? Now we have to show that these are the roots. Okay, how can you show this? So let me first copy and paste this. Okay, we have to show using this that these are the roots. So we will plug in alpha first. So let's try that. This will be alpha square and this will be alpha, beta, gamma. Okay, so alpha and alpha cancels out and we are left with alpha, beta, gamma. Do we have this? Alpha, yeah, we do. Now, if we were to repeat this for beta and gamma, we should satisfy this as well. So now let me input beta. So this would be beta square divided by alpha, beta, gamma. Beta and beta get cancelled. We are left with beta divided by alpha, gamma. Now for gamma, this would be gamma square divided by alpha, beta, gamma. Gamma, gamma cancels. We are left with gamma, alpha, beta. Do we have all three of these? Yes, we do. So this was the first part. A bit different questions requires analyzing. So now we have part 2 to solve. Second part is pretty straightforward. Let me copy and paste this. Let me copy and paste this as well. Let me copy and paste this as well. Okay, so in the last part, we actually found the equation for this substitution. Yeah, and we found the equation and we are told that this equation has these roots. All right, so these are the roots for this equation, right? Now if we notice carefully, first of all, the part 2 is asking us to show that this is equal to this. Okay, how can you show that? So this is pretty simple question. As you guys notice carefully, that this is actually equal to alpha, beta, gamma square. If we were to square the roots for this equation, we should get this. We should get this. We should get this. We should get this. So let me square everything. Beta square, gamma square. Similarly for this, we will end up with this and so on. So basically, this is sum of square of roots for this equation. All of the roots of this equation are being squared. So we have to find sum of square of roots for this equation. So how can we do that? We know that there is a universal pattern that sum of square of roots actually follow, which is this one. So we will simply apply this using our equation. So let's apply this. And this will give us S2, which is sum of square of roots, because the roots of this equation are being squared. Okay. So let's input the values here. So minus b, so minus 14 divided by 49, a is 49. Minus 2, c over a, c is minus 27, and a is 49. So we will end up with 4 over 49 plus 54 divided by 49, which is equals to 58 divided by 49, and we have proved this. Okay, so this marks the end for unit 1, roots of polynomials. We are done with everything. Derivation of Wheater's formula for quadratics, cubics, quartics, summation notation for roots of polynomials, sum of square of roots, recurrence, and substitution. So in the next class, we will hopefully start our second unit, which is rational functions. So that's it for me. Goodbye.